Hi everyone, I'm David. I'm the co-founder and CEO of Hunch. It's a data tool to bridge the gap between data analysts and business users. So does anyone know who said this? A basic problem about any body of data is to make it more easily and effectively handleable by minds. Any ideas?
Einstein.
Close, actually. He did know him. John Tukey said this, the mathematician, statistician. Probably none of us would be here if it wasn't for him. And he said it almost 50 years ago. And of course, a lot of time has passed since then, and I don't think anyone would say that this problem has been solved. And it's perhaps it can never be fully solved. But the question that we're interested in is it possible to do better than today's tools? Is it possible to make it easier to make sense of data? All right. So I became really interested in this topic when I was working as a management consultant and analyst. I read the works of two people, Edward Tufte, who wrote about how powerful data visualizations can be in helping you to make sense of the world, and John Boyd, the originator of the OODA loop, the fighter pilot and military strategist, who showed that rapidly making sense of the world is literally the key step in this loop of survival. It helps any organism survive and thrive in a dynamic world. And that describes all of us and all of the organizations that we work with. So I worked, that's interesting. So I worked I co-founded a startup called Cape Networks a few years later, and we put some of those ideas into practice. So we built software that helped network administrators, many of whom were not experts, make sense of complex networking data really quickly. And in the process of doing that, we learned a lot about how to make it really, a lot of data really interactive and really performant. But what's kind of ironic is that we had a whole lot of our own data, a whole lot of sales data, operational data, finance data, and we faced, even though we were building a data sense-making tool ourselves, we faced a lot of the same challenges that data teams face everywhere in making sense of their data. So after Aruba Networks, which is Cisco's big competitor, acquired Cape to be the face of their software portfolio, my co-founders and I decided to take what we'd learned and apply it to more data, more business data. So we founded Hunch, which is a shared canvas for both data analysts and business users to collaborate, to work together, to make sense of data. It's really visual, it's spatial, it's fast, and I want to share some of our learnings to date. So just a couple of things to bear in mind. Until about 2 weeks ago, we were just 3 people. We don't have a product, we're pre-product, so I'm not trying to sell you anything. But we've spoken to a lot of early users and had some great feedback. I don't know why these images aren't showing. A lot of great feedback from a lot of people. We're really grateful for, and I really want to share some of that, some of those learnings with you. Now, before we do that, before we kind of go into the learnings and the demo that Scott mentioned, is I want to start with why. Why is this a difficult problem to work on? Why should we try anyway? And why we think that latency is a really important part of both the problem and the solution. All right. So why is this hard? So the existing tools out there, SQL, BI interfaces, if you think about Tableau or spreadsheets like Excel, have been largely unchanged and used by millions of people, hundreds of millions of people in some cases, for the last 20 to 30 years. So they've really stood the test of time. So it's a big question. Is it even possible to build something that is sufficiently better? And if we do, it has to be better for 2 very different sets of people. both analysts and business users. And they have very different needs, very different skill levels. So that's also extremely difficult in and of itself. And then third is once you have potential designs or hypotheses about what could potentially work, it's not sufficient just to make a few mock-ups and to show people and ask them what they think. You have to actually, the only way to validate that is to try it out, to feel what that software feels like with a very diverse set of data. So, what happens if you've got data sets with lots and lots of columns, or with lots and lots of rows, or very few, or fields with very high cardinality or low cardinality, all the different data types, all the combinations of those things. And what you start realizing is that building an MVP, there's not that much that's M about it. To make it viable, it really isn't minimal. So it's extremely high bar to actually test out your hypotheses and designs. And then, you're making something new and novel, but making it really performant. And as I mentioned before, latency is a big part of what we're trying to address. But making things that are both novel and performant is extremely hard. And there are tons of technical challenges. There's trade-offs that you have to make, both technically as well as how you work, the kinds of people and skills that they need to work on the project. And lastly, there's more than 50 years of history in this space, hundreds, if not thousands, of successes and failures to learn from. There's tons and tons of research, more and more over the last 10 years or so. And there's so many other people working on this in this space on this problem. So how do you learn from what other people have done and still approach the problem with a beginner's mind? So to do this, you need to be able to build a better data experience, and you have to be crazy enough to try to build a data experience. And we're definitely somewhere in on the right-hand side. All right, so why try? This is a slightly different version of the Matt Turk image that has been shown 100 times so far in the last couple days. But because there are so many different players, because the market is crowded, it's a hint that there's a real problem there. And there isn't one dominant solution that is so much better than everyone else. And all of those products, all of those companies were built in a slightly different time. There have been so many things that have happened in the last couple of years that really change what is feasible and really some of the requirements for a really great data experience. So for example, the changes in the last couple of years with data, now we increasingly have all of our data and metadata in one place with a modern data stack, the semantic layer. We also have very different behaviors and expectations in our work. In addition to just more data maturity in our organizations, we're now used to very collaborative multiplayer SaaS tools, whether it's Canva, Figma, Notion, etc. And it really feels like it's time for a modern collaborative data tool. And lastly, and I think actually the most importantly, we've obviously been talking a lot about LLMs and their potential during the last few days. But in addition to that, it is now possible to have really, really fast queries, which enable really fast interactions with data, with technology like ClickHouse and DuckDB. So, speaking about speed, I want to talk a little bit about latency. This is a really simplified model of how we make sense of the world. So we ask questions, we learn something based on the answer to those questions. That enables us to ask better questions and to learn even more useful things, get better insights and better questions, and so on. And anything that gets in between these two activities is a problem. So any latency or friction. And there's latency operating at two very different levels when it comes to interacting with data. One is at the organizational level, where you have, as a business user, you're asking a question. That question is then put in a ticket and prioritize and put on on a queue for someone to eventually analyze it and come back to you. So then you ask more questions and so forth. So that's a sort of organizational latency. And then the second is a product interaction level, where you're actually sitting in front of a product, either as the analyst or the business user analyzing the sort of results, and you're curious about something, or you're trying to figure out something, and then you have to wait for queries to execute and for the response time. So let's go back here. So for organizational latency, you have really long lead times, really slow iterations, and that really limits the number of useful questions and insights and decisions that you can make as an organization. And then on our product latency level, we could talk a lot. We could spend a lot of time talking about this and the next few slides, but I'm going to try and move through them quite quickly, is that there's a lot of research that shows that even modest amounts of additional latency in software dramatically changes user behavior. There seems to be a breakpoint at around 300 to 500 milliseconds where productivity really has a step change, where people become significantly less productive, this is both like back in the kind of mainframe days with search, with commerce, but even with data. So Zicheng Liu and Jeffrey here showed that even with just a 500 milliseconds delay, it significantly decreased usage for visual analysis and changed how people explored data. So what are the potential solutions to this, especially if we limit the scope of this to data tools, to software that we use? In short, it's really creating a shared space to reduce organizational latency, a space that more and more people can work in and can work more effectively together in, and to make all of their interactions with that tool much more productive. Okay. Now, we can break this down and continue breaking this down, and this is by no means mutually exclusive and collectively exhaustive, but I think that there's some really useful things here, at least in the way that we think about how to solve this problem. So firstly, in the sort of shared space, making it easy to learn, we need to build on what's familiar. People are familiar with SQL and Sheets, but for everything else, interactions that are unfamiliar, we need to flatten that learning curve as much as possible, make it really sort of rest on as few new concepts and interactions as we can, and make as many of those interactions really direct, so you don't have to learn them in order to start using the software. And then to make it more collaborative, you can make software collaborative both synchronously, sort of multiplayer fashion, or asynchronously, and take more advantage of the social dimension of working with data. So it's very useful to know what is the VP of sales looking at, or what is the data analyst on my team looking at, and use that as the way to find relevant information and to work together. And then in terms of making each interaction more productive, we want to keep people in a flow state, and that requires more than just what we're showing here, but two of the key pieces is one is making interactions very fluid, so you can fluidly go from exploration and exploratory work to creating assets, to explaining what you're doing, and back again, and also making each interaction really low latency. And then making every interaction high bandwidth as well. So we are visual creatures, we're pattern matching machines. We don't take enough advantage of that in our software typically. And also we think very spatially. Organisms developed brains in order to navigate through space. So space and spatial thinking is the sort of most fundamental level. So how did we go from kind of these guiding principles, these ideas about how to improve interactions, to actually building a product and trying out different approaches. So first thing we did, those are my co-founders, Ross and Alex. I'm based in San Francisco, they're based in Cape Town, and we've been working together since, Ross and I since high school. Alex, and Ross and I were at Cape together as well. Well, we took 10 days, we went to France together, we locked ourselves in an Airbnb away from our kids and every other distraction, and we covered the walls with every idea that we had about how to solve this, how, if we were really dreaming, what would be the best things that we could imagine. And we came up with a couple of different options, and we prioritized this one particular approach. We went back to our families, and we got building. Ross and Alex are the coders. I was working on the design, and also going back to some of the sacred texts. That is John Tukey's Exploratory Data Analysis. That's the book where the quote from the beginning of this talk was from. And within about a month and a half, we had our first prototype. And I'm going to step through it here. Hopefully the images in it sort of play ball. But basically the way that this worked is that for any data set that you were looking at, any table, any query result, every field was shown in a long list down the side, in a single lane. And depending on the data type, it was expressed as a frequency distribution chart or a time series chart or bar chart for the different data types. And you could sort of scroll down and see more. Let me just, I'm not sure why this is not cooperating.
Last suck of the day, man. That's what happens.
Yeah. All right. So we're gonna push through. We're gonna try and get through this year. So what you can do is to kind of explore the data that you have is grab any field and drag it into a lane, another lane. So in this case, we have shipping date. So that allows us to see sales by shipping date, quantity by shipping date, and every single other field by shipping date. So we didn't matter if it's a measure or a dimension, you just combine the data to explore it. And likewise, you can see the product subcategory as a new lane. So you can see that too. And it's a very, very quick way of exploring different potential relationships in your data. And you could then you can click to highlight any piece of data on the screen. So in this case, we click to highlight phones, and then that enabled you to see sort of phone sales by ship date, or the distribution of phone quantities, phone discounts, etc. And then you could grab any one of these charts and add it to a story to go from the kind of exploratory analysis to explanatory analysis. And that story can be shared with your organization. Now, the challenge, if you haven't already seen it, is that this is quite hard especially if you're not really kind of data literate, to make sense of and to follow along with. And it gets extremely hard as you add more and more different fields. So we took some of the learnings from here about how to, visualizing different data types and sort of some of the interactions that we had, and we tried to, instead of not having a single focus area, to try a different prototype which did have a focus area. So in this case, you took profit if you wanted to learn more about profit. and figure out what was happening. And then you could visualize profit by any other field. So in more of a kind of a stepwise way. So in this case, you see profit by state. You can change state to other options, or you can start faceting that by more and more fields, and adding those to a thread as well. But unfortunately, this had kind of the opposite problem, where you're focusing on a single field or single chart, and you're kind of losing context. You're immediately in the rabbit hole and losing context from everything else. So the next step from here was something that tried to give the sort of feeling of being able to explore your data and be flexible, as well as the ability to focus in on specific analyses. And that's our first Canvas prototype from about May last year. And it was really at this point that we felt that we'd really kind of gotten somewhere. And we immediately kind of we're able to see new insights in data by having the context of the whole data set and all the analyses, as well as something that was easily shareable. At the same time, we were experimenting with other approaches to enhance this. So an example is this GPT experiment. Now, we found very early on, which is the same thing so many people did at that point, was that using LLMs to generate code was pretty fraught, but using it to generate metadata, things which is stuff that's pretty useful, but people don't usually bother with because of the friction, it actually worked really well. So here we're generating potential descriptions for this data set. And then we took what we built, we started really showing it to more and more people. We've been showing it to people throughout this time, but we really kind of iterated and went deep with potential users, and we really took the time to craft every design detail as well. So for just a single little chart, on the point about how do you make things high bandwidth, by really taking care of the details of how every piece of the product looked and worked. So let me get to a demo. All right, this is what we have. This is what we have currently. So it's an empty canvas. You can connect it to a data warehouse and pull in data that way. What I'm going to do is, just to keep things really simple, is I'm going to take a CSV and I'm going to drag that onto the canvas. So here we have order line item data. So order references, product names and categories, and information about each of those order line items. I'm just going to drag that onto the canvas. So it's uploads and processes, and we have all of the fields from that CSV here. And we've done a lot of profiling to look at what the statistics behind them and figure out how to actually work with this data. It enables us to just drag any field that we want to look at or learn more about onto the canvas. So in this case, this is a product category. You can just drag that onto the canvas and it creates a chart for us. It's the distribution of product categories across all of our orders. I mean, if we want to know about sales by product category, we just grab sales and drop it on top. And because of this data typing system that we've built, it knows how to combine different pieces of information and make sensible sort of visualizations and charts out of it. But behind the scenes, it's really just primitives that we're all familiar with. It's just a table, and that table is generated by SQL, and so it's really kind of has this familiar feel to it as well. But there's a bunch of additional interactions to really kind of take advantage of the spatial dimension of the canvas. So, for example, you can just grab the side of the chart and gather up the very long tail of categories or see what's inside, or change the chart into a horizontal bar chart. You can also interact with the heading of the chart to reconfigure it. So we can look at the average sales by category instead, or the average quantity by category. And because we built the sort of primitives underlying this, it opens up some really interesting possibilities. So for example, you can grab the whole data set and drop it onto the canvas. And it gives you a bird's eye view of all the data inside that data set. And just like from that very first prototype that we created, you can click to select any data on this, anywhere on this canvas, and then highlights it everywhere else. So for example, if you want to look at what's happening during these months, you can just click and highlight and focus in on that information. All right. One more interaction with mentioning is that you can just drop on an additional data set. So this is something that's often really difficult to do. You have to, if you want to combine data from multiple different sources, you often go through data engineering, or if you are using Excel or something like that, you can do VLOOKUPs to combine data. But in this case, you can just drag it onto the canvas. We find the relationship between different data sets, which you can modify, and it's there and connected so that you can look at put all this data together. So to put all this together, you can, for example, take states from the deliveries data set and sales from the line items data set, the order data set, and see sales by state. Let's actually take a look at more states here. And then to see which states or what proportion of total sales across your states have very high discounts. We just highlight the high discounts on the first data set, and it shows up on this chart. So you can see all of that Texas, for example, Pennsylvania, Florida, Illinois, etc., have really quite a lot of their sales are very high, driven by very high discounts, whereas that's not the case in California, New York, and Washington. So it's very fluid and interactive. We did a lot to try and make this very, very responsive, and I'm going to show you a little bit about how we did that. Okay. So making really bespoke interactions and making things really performant is not easy. There's quite a trade-off between that and really building things fast using standard libraries, low complexity. So if we were to take a canvas over here and look at, okay, if we were to just highlight on this canvas, what exactly happens? All right, this is going to show us. So you've got, it's really quite hard to optimize the performance of this because you don't have pre-computed dimensions and measures. It's very flexible. You can click and select anywhere. You can click on unmaterialized data. So for example, if you change a chart to sales by day of the week, there's no data set with day of the week. That's not a new column or whatever. That's just transformed and unmaterialized. You can stack up criteria to really make complex selection criteria. And you can do this across multiple data sets. So all of these charts need to update as quickly as possible, preferably in less than 100 milliseconds. Now, what is actually happening here? Well, what's happening is that we need to basically redo the queries for all of the charts, for all the tables, for all the statistics, for all the fields, for all the titles for the charts. So for each of these items, we need to update the queries. And so for each of these entities, each of these components on the canvas, there are 3 queries: the highlight condition, the base and join, and the chart that comes out of that. So those all get combined into a single query to be executed. But across all of the components, we're talking about lots and lots of queries that are generated, and then they're combined, so you ultimately end up with at least dozens of queries to be executed, all in parallel. And that's really hard to do fast. And that's just one example of an interaction. We also have other kind of canvas-wide interactions, like when you convert the highlight to a filter, and then it has to update the base data across all the charts, when you add a new data set to a chart. But we also have interactions that are much more localized, like when I adjusted the size of a chart, we did all of that on the front end, or at least as much of that on the front end as possible, and then reconciled that with the back end afterwards. And then there's interactions in between. So you've got all of these different types of interactions that all have different strategies for making them really performant. So, we are, Hunch is being used by some design partners. We really appreciate their feedback. If you have any feedback, if you want to try it, you're welcome to. Really at this point, love talking about what we built and how we can improve it to better solve your problems. So, yeah. Thanks very much.